Yes, welcome to DC Economics. I'm going to take you on how we can calculate the steady state level. So this is a concept in calculus, in mathematics, and we are not basing here on macroeconomics. So a steady state for differential equation is a solution where the values of y does not change over time. In another way, the steady state in physiological is also known as homeostatic, the system in which a particular variable is not changing, but energy must be continuously added to maintain its variables. So when you try to analyze the steady state level in mathematics, what we need to be careful is to look on what factor actually is constant when other variables keep moving or changing. The steady state is obtained by solving the dynamic equations for dx over dt, which is equal to 0. This means that derivative change of dx over dt is equal to 0. So the steady state values of the system variables and some parameters for these processes are given below. That we have the dt over dt, which is equal to 0. And this is actual regard it as a steady state level. So it will be better we go further and look some different examples so as it can be easier for us to capture the concept. But you need to understand, let's consider a differential equation that is y, which is equal to ay. Is the y estimated is equal to ay. In order for the level of y to be the same this year and last year, we must have that y, which is equal to 0. So we keep y is equal to 0 so as we can obtain the steady state level. Now let's look this now brief example. Find the steady state for the equation that is y estimated is equal to b plus ay. So since we let out the y estimated is equal to 0, so which is equal to b plus ay, when you take out ay, you make up the subject, the values of y, it will be equal to 0 minus b. So it will be ay, which is equal to negative b over a. So when you cross multiplication over there, you divide it by a both sides, you obtain y, which is equal to negative b over a. So from that case, that is a steady state level. So when you find the steady state level, you need to account one of the values equals to constant, that you equate it is equal to 0. Then you solve the required value in the given function. So the steady state of the function, that is y estimated is equal to b plus ay, is equal to y is equal to negative b over a. For example, if y estimated is equal to y squared minus 4y estimated plus 3, we require to determine the steady state and their stability. Let y estimated is equal to 0. So y estimated is equal to 0, that is 0 is equal to y squared minus 4y plus 3. So we take out negative y minus 1, then times y minus 3. So y minus 3 is equal to 0. So let you take out, when you apply it out there, when you try to simplify the equation, it will be negative y minus y, that is y plus y minus 3 is equal to 0. Let you solve the values of y from the given function. You may apply even the calculator to solve this kind of a linear equation, this kind of an equation on the second degree. So the values of y will be equal to 3 and y is equal to 1. Now from our equation, from the original function that is y squared minus 4y estimated plus 3, let's find the dy over dy, that is equal to, we apply this derivative, that is 2y minus 4. Now after apply the second derivative, now let's determine the steady state level on this particular function. That will be equals to dy over dt, second derivative is less than 0. So when you apply this, the first derivative of the function and be less than 0, the condition is known as a stable. And if the dy over dy ly is greater than 0, then the function is unstable. So these are the conditions for stable and unstable of the given function when you're trying to calculate the steady state level. Now from that case, from the equation 1, from the original equation, that is dy over is equal to 2y minus 4, let you plug the values of y that you've obtained previous. So it will be 2y minus 4, that is equal to 2. Let you start by plugging the values of y, that is 1. That will be equals to 2. That will be equals to, let you start plugging the values of the equation, that is y is equal to 3. So we plug 3 to the y minus 4. The answer will be equals to 6 minus 4, that is 1. Now second, take the first order derivative of the function, that is the same function, that is 2y minus 4. Let you plug 1 to the equation. Now before that, the answer is 2. So since 2 is greater than 0, we may conclude that the value is what is known as unstable. So since the values of 2 is greater than 0, that is an unstable value. We plug in the value of y, which is equal to 3, to the steady state, to the function. This will give you dy over dy is equal to 2y minus 4. Let you plug in the value of y, which is equal to 1. The answer will be equal to negative 2. Now since negative 2 is less than 0, the value proves that it is stable. As you can observe, so the value of the steady state level on this particular function is y is equal to 3 and y is equal to 1. So these are the conditions for a simple test for stability. That is, the first order derivative, if it is less than 0, then the steady state is stable. And if the dy, the first order derivative of dy over dy is greater than 0, at a given steady state value, then the answer is unstable, as you can observe. So those y star represent the y at the steady state level, as you can observe. Now let's look at another example. Draw a graph of xt against xt minus 1 and label the steady state to explain whether it is stable or unstable. So let's try to perform these two examples over here. Let's begin with A and B. After understanding A and B, there will be an homework for yourself to perform on C so as to prove out your performance on what you have captured to the topic. So for example, we have now xt is equal to 2t times 1 over 3 xt minus 1. Now we require to graph out xt, that will represent of the y-axis, and xt minus 1 represent of the x-axis. So from xt, which is equal to 2 plus 1 over 3 bracket xt minus 1, let's take the value times xt inside the equation. That will give you xt. This will be equals to xt minus 1, which is over 3. So when we equate out xt is equal to 0, 0 will be equals to 2 plus xt minus 1 over 3. Now from that case, let you divide, take out 0 to the left hand side, then divide by, take out the value of xt minus 1 to obtain what you obtain. Negative 2 will be equals to 1 over xt minus 1. So let's divide by 1 over 3 both sides to obtain the values of xt, that is the y-axis. So the value of xt minus 1 will be equals to 2 divided by 1 over 3. This will be equals to negative 2, 1 over 3. That is negative 7 over 3. Now from this function of xt, that is y-axis, we need to find out what will be the values of what is known as the y-axis. So this is the x-axis. So the y-axis will be equals to taking 2 times 1 over 3 times negative 2 over 3. So we plug it to the function of xt, which is equal to 2 plus 1 over 3 xt minus 1. So when you plug the value of xt minus 1 to the equation, this will give you, this will be equals to, you take out 2 times, then 1 over 3 times negative 2 over 3. This will exactly give you xt will be equals to xt will be equals to the xt value So when you take out 2 plus 1 over 3 times negative 7 over 3, that is xt minus 1 function, that since you are plugging the value, the equation, the value will be equals to 1, 2 over 9, that is 11 over 9. So xt minus 1 is equal to 11, over 9, and xt minus 1 is equal to negative 7 over 3, and xt is equal to 11 over 9. So this proves out now the stability of the function. We need to differentiate the functions of xt. When you take out dxt and you differentiate with xt minus 1, this will give you 1 over 3 xt minus 1. So if it is 1 over 3, this means that 1 over 3 is greater than 0. So this proves unstable of the steady state level. So this proves that it is unstable. So when you try to sketch out the graph, so since we have 11 over 9 and we have negative 7 over 3, so we'll be having 1, 2, 3, 4, 5 for the positive values and negative values, that is negative 1, 2, 3, 4, and 5, and you have the positive values as you can observe. So we need to take out the values of y-axis, that is xt. The values of xt is well known. The values of xt is y-axis and xt minus 1 is x-axis. So 11 over 9 is equal to, when you put it in a decimal place, it's like to say it is 1.2. So when you sketch out, this will actually resemble to be at this point over there. It will be at the center between 1 and 2 over there. That is the value of y. The values of y it will be over there as compared to the y-axis, and the x-axis is 2.33, so it will be somewhere there, and it is negative. So since the value is unstable for the function, this means that the values will cut across going from the upward, showing up the unstable of that function like that, as you can observe. So let's go to part B. So 2xt is equal to 2 plus 3 over 2xt minus 1. Solution, we take out the value of 2xt is equal to 2 plus 3 over 2xt minus 1. So we divide by 2 both sides so as you can obtain the value of xt. So this will give you, this will be equals to 1, then plus 3 over 2 divided by 2 is equal to, when we take out this will give you, when you divide by 2, this will give you 3 over 4 xt minus 1. So xt will be equals to 0 plus, then 1 plus 3 4xt minus 1. So we equate it is equal to 0 so as you can obtain the steady state level value. So it will be xt minus 1 over 3 4 is equal to 0 minus 1. So when you solve out, you obtain the value of xt minus 1, that is the x-axis, is equal to negative 1 divided by 3 over 4. So when you check out negative 1 divided by negative 3 over 4, the answer will be equals to 1 over 3. It's like to say the answer will be equals to 4 over 3. That is equal to this will I mean that will be equals to 7 over 4, as you can observe. So that is equal to the x-axis value. So we need to solve for the y-axis value, that is xt. So we take the value of the y-axis, we plug into the function so as we can obtain the values of xt. So this will be equals to xt is equal to 1 plus 3 over 4 xt minus 1. So the value of xt is equal to 1 plus 3 over 4 times, we plug in the values of the x-axis, that is 7 over 4, to the function. So the values of xt will be equals to 1 plus 3 over 4 times 7 over 4. So this will give us, when you times over there, this will give out 1/5 over 16. So when you take out the values and solve the values of xt, it will be equals to 1 plus 3 over 4 xt minus 1, that is 1 over plus 3 over 4 times negative 7 over 4. So the values of xt will be equals to 1 plus the function, that is 1 times 5, 1 5 over 16. So this will exactly give us 2 5 over 16. So xt will be equal to, when you take out the value, 1 plus, then 1 negative 1 plus 5 over 16. This will be equals to negative 5 over 16. Now, since now we have already solved the value for y-axis and the x-axis, now it is possible to sketch out the graph. But remember, we need to prove out the stability and the stability of these conditions, as I told you. So we need to apply the first order derivative from the original function of xt. So when we take out xt, that is negative 5 over 16, the xt minus 1 is 7 over 4. So when you apply the first order derivative, the function that is xt is equal to 1 plus 3 over 4 xt, then minus 1. The first derivative, the condition, would be equals to, this will give you, it's like to say it will be 3 over 4. Now since 3 over 4 is greater than 0, now the function of the steady state, prove out it is, since the values of 3 over 4 is less than 0, I mean it is greater than 0, sorry. So the value will prove out that the value is unstable. Now since 3 over 4 is greater than 0, that is 0.75, that is 3 divided by 4 is 0.75. So 0.75 is greater than 0. So this will give out example, this will be equals to unstable value of the function. So you sketch up the graph over there. So you check out the values, that is 1.75 and 0.3125 over there. So remember xt minus 1, that is 1.75, is what is known as the x-axis, and xt, that is 0.3125, is the y-axis. So our graph will go straight forward like that, since we have then stable values of the function. So that is how we do. So that's marked the end. For more learning, don't forget to watch another videos and subscribe on my channel.